Good day everyone. This is Professor Maria Luisa Baitio Salingay inviting you to join me in my short discussion on solutions. In chemistry, solutions are expressed in various concentrations. Concentration can be in molarity, capital M, with the formula moles of solute over volume of solution in liter. The unit is moles over liter and can also be expressed in millimoles of solute over milliliters of solution. Molality or small m with the formula moles of solute over kilogram of solvent, expressed in moles per kilogram. It can also be normality or capital N. The formula is number of gram equivalents over volume of solution in liters, wherein the number of grams equivalents is equal to the mass of solute over equivalent mass of solute. Normality can also be calculated with the formula molarity times the number of equivalents, wherein the number of equivalents is equal to the number of H ion in acids, number of OH ion in bases, or the number of electrons involved in the reaction. N has the unit equivalents per liter. Solutions can also be expressed in mass percentage with the formula mass of solute over mass of solution times 100, volume percentage with the formula volume of solute over volume of solution times 100. For very dilute solution, it is expressed in ppm or parts per million with the formula mass of solute over mass of solvent or solution times 1 million. That is 10 to the power of negative 6. Or in ppb or parts per billion with the formula mass or volume of solute over mass or volume of solvent or solution times 1 billion or 10 to the power of negative 9. It can also be expressed in mole fraction with the formula moles of solute over moles of solution or moles of solvent over moles of solution. Mole fraction has no units. Discussion on solution, you need to review the following terms: mole, molecular mass, solute, solvent, solution, concentration, concentrated solution, and dilute solution. How to prepare solutions? As illustrated here, 500 ml of cobalt 2 chloride dihydrate was prepared by weighing the sample using a top loading balance. The weighed sample was placed in 500 ml volumetric flush. Solvent ethanol was added before the mark and shake to dissolve. Then ethanol was added to the mark and let it stand. For solution that need to be standardized, let it stand at least overnight. In weighing samples also, analytical balance enclosed with glasses is preferred to avoid air disturbance and accurate until 0.1 milligram. Solution can also be prepared in a different manner. If 250 ml solution is needed, a maximum volume of solvent was prepared. But at the end of the preparation, you notice that 45 ml of the solvent remained. This is because the sample ammonium dichromate has corresponding volume when dissolved. Let's go to exercises on solution. Number 1, How many grams of sodium hydroxide pellets is needed to prepare 1.2 liter of 3.5 m sodium hydroxide solution? Let X be the mass of sodium hydroxide pellet. The formula for M is equal to moles over volume of solution in liter, or equal to mass over molecular mass over volume of solution. So 3.5 m is equal to X over 40 grams per mole over 1.2 liters. For X, you first transpose 1.2 and 40 gram per mole to the left. So you're left with X. X is equal to 3.5 moles over liter times 1.2 liter times 40 grams per mole. You cancel mole, you cancel liter, and you're left with grams. So X is equal to 168 grams. So you need 168 grams of sodium hydroxide pellets to prepare 1.2 liters of 3.5 m sodium hydroxide solution. Number 2. What is the molality of a solution prepared from 95 grams toluene dissolved in 950 gram benzene? Formula for molality is equal to moles over kilogram solvent. So it is equal to mass over molecular mass over kilogram solvent. So M is equal to 60 grams over 92 grams per mole over 0.950 kilogram. You cancel gram and you're left with mole per kilogram. So M is equal to 1.0870 mole per kilogram. Number 3 problem. What is the molarity of the HCl solution if 7 ml of the solution is titrated with 26.4 ml of 0.170 m sodium hydroxide solution? This is a neutralization reaction that asks for the concentration of HCl, which is the acid. You just substitute the values of the acids and the base in this equation, which is MV acid is equal to MV base. Then you get the molarity of HCl, which is equal to 0.170 m times 26.4 ml over 7 ml. You cancel ml, you have left with molarity. So concentration of HCl is 0.641 molarity. Number 4. What is the normality of a liter of solution when 120 grams of barium hydroxide is dissolved in water? Formula for N is equal to molarity times number of equivalents, which is equal to 120 grams over 171.34 gram per mole over 1 liter times 2 equivalents per mole. You cancel grams, you cancel mole. N is equal to 1.4007 equivalents per liter. Number 5. How much 6.0545 m HCl stock solution is needed to prepare a liter of 3 m HCl solution? You let X be the volume of the stock solution needed. The formula to be used in this problem is equal to MV initial is equal to MV final. So M initial concentration of HCl times the initial volume of HCl is equal to the final concentration of HCl times the final volume of HCl. So you just substitute the values. So 6.0545 m times L is equal to 1.5 m times 1 liter. So X is equal to 3m times 1 liter over 6.0545 m. You cancel molarity, you are left with liters. So the initial volume of HCl is equal to 0.4955 liters, or number 6. How much water is added to prepare a 2 liter of 1.5 m sodium hydroxide solution from 500 ml of a freshly prepared 6M sodium hydroxide. Let X be the volume of water added. So the formula to be used is MV initial is equal to MV final. Take note that in the final volume of sodium hydroxide, you consider the volume of water added, which is what is asked in the problem. Substitute the value, so this is equal to 6m times 0.5 liters is equal to 1.5m times 0.5 liters plus x. So 6m times 0.5 liters over 1.5m. You transpose this to the left. Is equal to 0.5 liters plus x. Cancel molarity, you're left with liters. So you have these values is equal to 2 liters equal to 0.5 liters plus x. You transpose 0.5 liters to the left, so 2 liters minus 0.5 liters, x is equal to 1.5 liters. This is the volume of water needed for this dilution problem. Number 7. How much of 2.5 N sulfuric acid solution is needed to prepare a 700 ml of 1M sulfuric acid? Let X be the volume of 2.5 N sulfuric acid needed. First, you have to convert normality to molarity. N is equal to M times equivalence number. So M is equal to N over equivalence number. So this is 2.5 equivalents per liter times mole over 2 equivalents. So 2.5 N is equal to 1.25 mole per liter or molarity. The formula to be used is MV initial is equal to MV final. So substitute the values. 1.25 M times X is equal to 1M times 750 ml. So X is equal to 1M times 750 ml over 1.25 M. You cancel molarity, you're left with ml. So X is equal to 600. You can also use liter instead of ml. So just the same. You just change liter from ml. So the final value is 0.6 liter. Be proactive. If you have comments, feel free to contact me on the following medium of communications.